welcome back to another exciting video about matrices. Today we're going to be talking about determinants and inverses of 3x3 matrices. The determinant of a 3x3 matrix is way more complicated to compute than the determinant of a 2x2 matrix. It is very important that you work accurately and efficiently as you calculate these determinants. The best way to go through and show you guys how to do this is to just do some examples. They get kind of crazy. Follow along as best you can, do some practice problems, and we'll figure it out tomorrow if you have any questions. For our first example here, we have two methods. We can use diagonals and minors to calculate our determinant. Diagonals is way easier, but minors has some cool applications that we can look at later, so I'm going to show you both. So first, let's start with diagonals. Actually use the pen, so diagonals. Okay, so here's what you do. Rewrite your matrix. -1, 2, 0, 4, 7, 1, 5, 3, 0. So rewrite the matrix. Then rewrite the first two columns. So -1, 2, 4, 7, 5, 3. Then you're going to go diagonally and multiply. So -1 times 7 times 0 is 0. 2 times 1 times 5 is 10. 0 times 4 times 3 is 0. You're going to add these together. Okay, this gives you 10. And then you go the other way, diagonal upwards, starting at this corner. So 5 times 7 times 0 is 0. 3 times 1 times -1 is -3. And then 0 times 4 times 2 is 0. I'm going to add these together, and this becomes -3. And then what you're going to do is you're going to take whatever you got going down this way and subtract it from whatever you got going down this way. So just like what we would have done had you been finding the determinant of a 2x2, which I think is kind of nice. Get rid of these lines a little bit because we don't need them so much. Okay, so you got 10 minus -3, which gives us 13. So 13 is our determinant using diagonals. Okay, the other method we have is using minors. Okay, minors is a little bit more complicated, but like I said, has some cool applications outside of it. So before we can do this, we have to look at this, a matrix of signs. Signs for a 3x3. Okay, that's this matrix like this. So it goes positive, negative, positive, negative, positive, negative, and positive, negative, positive. Okay, we're going to use that to help us here. So for the minors, you want to start with your initial matrix. Okay, so I got -1, 2, 0, 4, 7, 1, and then 5, 3, 0. Okay, so to start with your matrix of minors, what you want to do is go through and select one row that you want to expand it by. Okay, so I'm going to expand it by the top row. So once you've selected that, what you're going to do is you're going to block off each column for each entry in that row. Okay, so if I want to start at the start here, so start at -1, then I'm going to block off this column here. That gives me a minor matrix of 2x2 right here. Okay, so to set this up, you're going to take whatever number in the row you had. Okay, so I got -1 times the determinant of whatever this minor matrix is. So 7, 1, 3, 0. Okay. So that's the first part. Now, unfortunately, if I get rid of this, we have to do this 3 more times. Okay, so pick this one, and then you're going to get rid of this column, and that leaves you with another minor matrix. Okay, so this becomes 2 times 4, 1, 5, 0. Okay, now here's where it gets a little bit wacky. You have to use this matrix of signs, and that determines the signs that you put in front of your calculations here. Okay, so the first one was a plus, so I have a plus outside here. The second one's a minus, so I'm going to put a minus here. And then my third one is going to be a plus again, so then I have to go and actually calculate it. So let me get rid of these highlights again, not this one. Okay, and then we're expanding using the 0 row. So we go down this way. So it's going to be plus, I got 0 times the determinant of 4, 7, 5, 3. Okay, I know this seems just a little bit wacky, but sometimes it's useful. Okay, just sometimes. So then we can go through and calculate this. This isn't bad to go through and do it all. This is just -1 times the determinant of a 2 by 2. 7 times 0 minus 1 times 3. So I got 7 times 0 is 0, minus 1 times 3 is -3. Minus 2 times, I got 4 times 0 is 0, minus 1 times 5 is -5. Plus, well, this is just going to be 0 because it's 0 times something. Okay, and put all this together, you get 3 minus, well, plus 10 is equal to 13. For this second example, we can use both the same methods. I'm going to show you both again. We can use the diagonal method. I'm just going to do that right here and then rewriting 1, -1, 4, 2, 0, 0, and then go diagonally. So go this way, you get 0. Go this way, you get 24. Go this way, it's negative right there. Go down this diagonal and you get 0 again. Go up, you get 0. Go up this way, you get 0. Go up this way, you get positive 4. And we have 24 minus 4 is equal to 20. Okay, there's your determinant. Alright, then let's use the other method of using our minors. So to do this, write out your matrix again. 1, -1, -4, -2, 0, 0, 1, 3, 2. And you may be asking yourself, Mr. Babcock, why are you showing this to us again? Well, it's because you do not need to pick a single row, or the first row, as your row that you're going to look at. You could pick any row that you want. So, for me, when I see this problem, I see 2 zeros right there. Alright, so I'm actually going to do a column. I'm going to expand this using columns. Okay, so if I do -2 as my first minor row, I'm going to cancel off those, so it's going to become -2 times my determinant of -1, 3, -4, 2. And then the really nice thing that's going to happen is if I get rid of this and this, and pick this one right here. If I get rid of this entry, this is going to go away, but it's going to be 0 times the determinant of whatever that is. So plus 0 times the determinant of 1, -4, 1, 2, plus, if I do the last one here, let's get the eraser, the last one here, it's going to be 0 times the determinant of 1, -1, 1, 3. And those are just going to go away, which is really, really nice. There's one thing you have to be careful of, though. If you remember from earlier, where I had this matrix of signs up here, okay, that's really important because notice our -2 is negative, so we have to flip the sign. So this should become positive. Let's write that down. Positive due to matrix of signs. And then this, putting it all together, just becomes 2 times -1 times 2 is -2 plus -12, well, minus -12. So it becomes -2 minus -12 is equal to 2 times 10, which is equal to 20. Okay, so that's how you would do example 2 using minors or diagonals. Okay, this is where it gets really, really fun. So we can use all the stuff that we've done to find an inverse of a 3 by 3 matrix. And it's not easy to do. All you have to do is calculate the matrix of minors, turn that into the matrix of cofactors, transpose the matrix, and then multiply it by 1 over the determinant. So let's start by finding the determinant. So the determinant of this matrix here, so determinant of A is equal to, I'm going to write it out, 0, -3, -2, 1, -4, -2, -3, 4, 1. I'm going to use my diagonals because it's just a little bit more efficient here. And then I have -3, -4, 4. So go along my diagonals here, down this way, you get 0, down this way, you get -18, and down this way, you get -8. So then you go upwards like this, and you get -24. And up this way, you end up with 0. This way, you get -3. Add those together, you get -27. Add these together, you get -26. And then I do -26 plus 27, because it's really minus, and this is equal to 1. So the determinant of A is equal to 1. Alright, so that's going to make it really easy when we go to divide. It's almost like it was intentional. But here's what you have to do this. Okay, so start by saying 1 matrix of minors. Okay, so this is completely and utterly crazy. Okay, it's going to get real extreme, but we'll be able to get it done. So make it this giant matrix right here. Okay, so same method as what we used before, except this time you're going to go entry by entry. So start with A sub 1 comma 1, and that's going to block off this column and this row, or row and column, and that gives you this matrix here. Okay, that's your matrix of minors for your first entry. You don't need to do any multiplication. You can just write it down. So this becomes -4, -2, 4, 1. And notice that I'm going to be taking the determinant of this. Okay, so the next one I want to go through is, let's get rid of this stuff. Actually erase it. Okay, so the next one, start here. That gets rid of this column and this row. So it's the determinant of 1, -3, -2, 1. And then do the same thing again, except this time pick this one, get rid of this row and this column, and it becomes the determinant of 1, -4, -3, 4, like so. And then you're just going to keep going through and doing this, and you're going to end up with this massive matrix. Okay, so I got -3, -2, 1. This one's going to be 0, -2, -3, 1. This one's going to be 0, -3, -3, 4. Okay, and I just got these by doing that same process up here. So the eraser, I go through and I say, okay, pick this one, and I block off these. Okay, so that's -3, -2, 4, 1. And I get that same thing down here with my matrix. Okay, so you just keep going through and doing that, and you're going to end up with this matrix of determinants. Okay, so this is -3, -2, -4, -2. This one is 0, -2, 1, -2. And then I have 0, -3, 1, -4. Okay, and then you just have to go through and actually evaluate all of these determinants. Because I know all of you know how to evaluate determinants, when you go through and do this, you get 4, -5, -8, 5, -6, -9, -2, that should be a 2, not a 3. That's what happens when you're just copying from a worksheet. Okay, so that is your matrix of minors. That's this thing right here. Okay, then you want to take that and find your matrix of cofactors. So that's using that thing that we did before. So that matrix of signs. So matrix of cofactors. Okay, so to do this, you bring down your matrix. It's 4, -5, -8, 5, -6, -9, -2, 2, 3. And you're just going to use your matrix of signs for a 3 by 3, so plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so actually write that in the right order. So your matrix of cofactors is going to be 4, 5, -8. So that means flip the sign, not make it negative or make it positive. This here just means flip the sign. Okay, so you got 5, -5, -6, 9, and then -2, -2, 3. Okay, so there's your matrix of cofactors. Then after doing that, you just have to transpose on the diagonal. Okay, so all that means is that given your matrix, so I got 4, 5, -8, -5, -6, 9, -2, -2, 3. So all that means is on your diagonal here, you're going to transpose across. So 5 switches with -5, -2 switches with -8, and -2 here switches with 9. Okay, so let's rewrite that. This is for -5, because it flips, -2, and then I got 5, -6, -2, and then I have -8, 9, 3. And this matrix here is your transposed matrix. Okay, so this one, we're almost done. For step 4, you're just going to multiply by 1 over the determinant of A, which in this case is just 1 over 1. So you're multiplying by 1 over 1, so that's not really anything. So what you end up with is A inverse is equal to 4, -5, -2, 5, -6, -2, -8, 9, and 3. So that's your inverse. And if you don't believe me, let's check and find out. So you're going to write down 0, 1, -3, -3, -4, 4, -2, -2, 1. If you guys remember, that was our original matrix up here. Okay, so that was the original matrix up here. So if I multiply these two things, it should end up being this matrix here. You may be like, Mr. Babcock, why aren't you going through and doing that? That's because I know it is the inverse because I did everything right. And I checked it on my paper. I'm going to leave you guys to check this. And remember, whenever you check an inverse, you don't only have to check A times A inverse. You also have to check A inverse times A. These both need to be equal to your identity matrix. Okay, thank you guys. Have fun watching and doing the practice problems.